Okay, so today we're going to focus on solving a right triangle. How many parts does any triangle have? 6. 3 angles, 3 sides, right? What we're going to focus on is, besides the right angle, the 90-degree angle in a right triangle, if you are given any other 2 parts, and it doesn't matter what the parts are, we should be able to find the remaining 3 parts. So whether they give us 2 sides, if they give us an angle or a side, or if they give us 2 angles, we should be able, at this stage, to find the remaining 3 parts. So for this exercise, you will in fact need a calculator. So if you don't have any, the calculators are in the back of the room there on top of the Chrome cart. So please go ahead and grab a calculator. Okay, so what we remember from before with labeling a right triangle, that we will typically use uppercase letters for the angle measures. So if we have triangle A, B, and C here, the sides opposite, lowercase, will represent the side lengths. So if this is angle A here, the side opposite angle A would be the segment BC, and we'll label that lowercase a. Our hypotenuse is C here, capital C. So the side opposite here, or right angle C, our hypotenuse would be lowercase c, and then that would be B there. So the claim is, if you're given any 2 parts of a right triangle, we can find the remaining parts. So let's say we have this right triangle. And we have side length of 25 and a side length of 18. Okay. And we're going to label this as A, B, and angle C. So, how can we find the other parts? Namely, the angle measures and this missing side length here. Well, the missing side length, we've kind of known how to do that one since middle school. You have 2 sides of a right triangle, we can use Pythagorean theorem to find that 3rd side, right? So this missing side here is our hypotenuse. So we know that c squared is equal to 18 squared plus 25 squared. C squared is equal to, so 18 squared is that 324? 25 squared is 625. So c squared is equal, 5 and 4 is 9. So 949. So c is the square root of 949. So what is that as a decimal? 30.805, so we'll go with 30.8. For exact value, it would be the square root of 949. For an approximation, so you have to take a look at the what the directions are to any assessment. So in the book here, it's telling us to round values to the nearest tenth. So we would write this as 30.8. Now, the interior angles of any triangle, what must they add up to? What's the sum of the interior angles of a triangle? 180. So really, if we just found one of these angles, we can find the other one, because we already know this one's 90. These 2 angles are going to be complementary. What does complementary mean again? Okay, so 2 acute angles that add up 90 degrees. Okay. So now we just have to kind of figure out how we're going to find this angle. So let's go ahead and label this angle here theta. And we're going to go by the original side lengths that were given to us. And that was this 18 and this 25. So from the perspective of this angle theta, this side is opposite. This side is adjacent. Which trig function deals with opposite and adjacent? Tangent. So tangent of theta is equal to 18 divided by 25. So now let's take the inverse tan of both sides. So the inverse tan of tangent of theta is equal to the inverse tan of 18 over 25. So the inverse tan of tan, they undo each other, and we're just going to be left with theta. So theta is equal to the inverse tan of 18 over 25. Now here I do believe that your answers are in degrees. So please make sure that all of your calculators are in degrees. And let's evaluate what this is going to be. So we want the inverse tan of 18 over 25. So our trig, again, is above pi. So second trig. Inverse tan, I believe, is number 6. So inverse tangent of 18 over 25. And I already see that I have a mistake because I have not changed my calculator from radians to degrees. So let me do that. So my mode, I want to make sure my mode is on degrees. Okay, so now that I'm on degrees, okay, so I ended up with 35.75 degrees. So here, if we're rounding this to the nearest tenth, so we end up with theta is approximately equal to 35.75 degrees. But if we're rounding this to the nearest tenth, we can say theta is approximately equal to 35.8 degrees. So we started off where we were given the right angle, two sides. We found the third side through the Pythagorean theorem. We found one of the angles using tangent. So theta is 35.8. So now what is our missing angle measure? Our missing angle measure, so angle A, measure of angle A will be 90 minus 35.8. So that's going to give us 54.2. So angle A is 54.2 degrees. Angle B is 35.8 degrees. So now we have solved this right triangle because we have all six parts. So of a right triangle, in a right triangle, you're already going to have one of the parts, the right angle. If you're given any two other parts, you can use your inverse trig and trig to find the remaining parts. That's it. I said it wasn't going to be too bad. All right, so let's take a look at one example.
Wait, so why we learn all that other stuff? So, like, is the other stuff still going to come back into play?
Yes. All right, so let's take a look at another part. Okay, here. All right, we have the following. Let me move this over. All right, so we have the following. Let's see if I can get this in here. All right, so a kite. A kite flies at a height of 30 feet when 65 feet of string is out. So if the string is in a straight line, find the angle that it makes with the ground round to the nearest tenth of a degree. So here we have some kite, and that kite is 30 feet above the ground, 65 feet of string, and we're going to assume that your string isn't wavy, that the wind is blowing pretty hard, so your string will form a straight line there. So we want the measure of the angle that's formed with the ground. So we want that angle there. Okay, so which trig function would you use in order to find that angle? Why sine? Opposite over hypotenuse. So here's our ground here. Here's our string there. So that angle there. So sine of theta is equal to opposite, which is 30 feet, divided by hypotenuse, which is 65 feet. Okay, so, but that tells me what sine of theta is equal to. We want theta. So where do we go from here?
You do the inverse sine.
Inverse. So inverse sine. So theta is going to be the inverse sine of 30 over 65. So when you plug that into your calculators, what do you get? So if sine of theta is 30 over 65, then theta is the inverse sine of 30 over 65. One of the things that we really need to focus on is that whenever we look for inverse trig, you're always looking for an angle measure, whether it be in radians or degrees. So what did you guys get?
449.
So 27.49. So round to the nearest tenth. So it would be 27.5 degrees. So the angle that is made with the ground flying that kite would be 27.5 degrees. Okay.